manufacturing plant at this stage. It's a tube, it doesn't have any of the tapering features that you need to actually load the projectile in it. So it fits as a drop-in replacement to brass in commercial and government ammunition suppliers' machines to do the rest of the process, to basically assemble it into a projectile and do the load, assemble, and pack process that they do now. So it's a lightweight drop-in replacement to brass ammunition. That's a single-piece stainless steel. So CTC actually has a patent on the process. We didn't invent metal injection molding. We just have the patent for the application of case technology. So we applied it to that. In this case, this is what CTC is really good at. We had done that analysis and said, you can make these with metal injection molding. We went out to industry, to a number of different companies, and they told us we were crazy. They said there's no way you can metal injection mold those thin walls that you need on that case. But we had done the finite element analysis in the background and proved that we thought we could. So we sat there and went, well, everyone says we can't, but we're pretty sure we can based upon our models. So we bought a molder, put it in our shop, and we made some molds, and we did it. So now we've since transitioned that process to one of those injection molding shops that told us they couldn't. We told them how, and they now took it over, and we transitioned it to that, which is what we do. We develop it and transition it. So that was that project. Say parting thoughts, but I feel like give you a little background. We are looking for an intern this summer at CTC. It's out there on CTC's website. It's listed as mechanical engineering intern. So if anyone's interested, please apply quickly. We have a couple candidates interviewed, but I'd like to get the best one there. So just wanted to give you my insight as a hiring manager as to what I look for when somebody walks in, and not necessarily as an intern, but at all levels. I kind of already expect that you have the certificate, or you're working on the classes, you're passing them, you're in the program. You know, the engineering part of this you have under control. So what am I really looking for? I'm gonna ask you questions to see if you can think and if you can solve problems. Can you clearly communicate with me? Can you present your ideas? Those things stand out, they matter. They matter with clients, they matter with project teams, they're important. Can you work independently and as a team? Because there's times for both. And are you willing to keep learning? Do you have the motivation basically to achieve your goals? Along those lines, my advice, make sure you communicate with everyone often. That's super important. I know as engineers sometimes that's not the first thing you think to do, but it is the thing that is necessary as you advance through your career. Find a mentor, ask for advice, network with people, work as a team, and build relationships and trust with your clients and colleagues. So those are my keys to success. Any other questions? Yeah.
Towards the study that you guys did with the metal injection on the casings, was there any economic benefit to using stainless compared to brass, or was it a more expensive alternative?
So the stainless case is more expensive than the brass case. Yes. So the cost of copper right now is kind of going through the roof. So there's some benefit to moving to stainless for that. But yeah, it was absolutely, there is a cost impact. And we were making everything at a little scale, right? Little prototype scale. We did a lot of studies as to how to scale that up, as to how the cost decreases as you go from small production batches into large batches. And it gets close, but it's still a little bit more. It's solely based on material costs as the driver. But yes, there are. In today's world environment, there's actually a lot of people interested. We're working right now to commercialize it with another.
How How did you end up transitioning from engineering into project management?
So good question. How did I transition from engineering into project management? It was a slow process that I didn't realize was happening. Actually, as an intern, they gave me a program to manage because the guy managing it didn't want to do it. It was an electric vehicle consortium, and it was just basically managing vendors. So I started that. I kind of liked it. What's not fun about being in charge, right? So, so I kept getting more and more opportunities along that way as things moved on, and I'd work on projects, and as opportunities came up, hey, do you want to manage this? Hey, do you want to manage that? And the Navy project is what I probably, when the real transition happened from technical to some project management, it was some of the larger Navy efforts. Started small, liked it, and just kept on going.
Steve? I know you said you like to travel. Have you been able to travel with CTC at all?
So that is one of the really cool things that I am thankful for my work there. I have been on a lot of different shipyards all throughout the country, which I love the beach, so the shipyards are usually right close to the beach, so that was always a perk. But yes, I've been at many of them, got to see their manufacturing processes, just the scale of that is overwhelming. And I will tell you that I don't think they pay the welders that sit in these little compartments and weld all day in those tiny little things enough money, and I would never do it. But you get a big appreciation for what people do every day. And yes, so a lot of things I've been to a lot of different manufacturing facilities, seen a lot of cool stuff that I wouldn't have otherwise been able to do. Yeah, it's a major perk in my opinion. So. Anything else? Right. I have some CTC things if you want me to, otherwise if everybody wants to.
We got a few.
You all right? All right. That's it, but this is the overall CTC. I gave you that spiel. I just want to show you some of the cool projects we do have. So we have 4 major divisions: energy resilience and sustainability, engineering and manufacturing, which is the division I'm in, information technology, and readiness. The energy guys do a lot of policy planning, advise different facilities, make sure they have the proper infrastructure, all that good stuff. Engineering and manufacturing. Design, development, prototype, and transition to the client. Friction stir welding is, I think I have a slide on that. Additive manufacturing, systems engineering, design integration, the ammunition stuff, general design and analysis. We are getting into the digital engineering side of things. Digital thread, basically starting from your requirements, linking your requirements to your design decisions, into your prototyping and testing and understanding the results you get back from your test. What does that mean in regards to the requirement or the initial design? Really keeping that full picture of the digital design and thread going. That's a big buzzword in engineering today. So friction stir welding, this is something that everyone thinks is really cool, and it is. We do have a friction stir weld machine at CTC, and basically it's a welding process. It takes an electrode, spins it really fast, and joins materials together. The benefit of friction stir welding is that you don't have a heat affected zone. When you weld, things heat up, move, distort, like I said before, and your material properties in that weld area are actually worse with most conventional welding processes. Friction stir welding does not have that issue. It has no heat effective zone, better material properties, and allows you to join sometimes materials that you can't do with other welding processes. So it's quite an impressive process. There's a lot of application in the military world for that, for high strength welding, tank structures, and we have a boat project and some other things right now. the ammunition one. I don't know a whole lot about this one, but we do have rare earth elements project. They're extracting the elements from coal-based sources. Project is looking at how to do that, make it economical. This is one of the shipyard projects. Made a little system to, instead of having to replace panels on the ship, they can put a reverse sensitization unit on there and basically make the aluminum properties come back to what they need to be, so they don't have to replace. The IT world is big into AI and machine learning. We do have an effort on the friction stir weld machine to do a machine learning application there right now, so it's cross-divisional. It's a bunch of cybersecurity stuff, edge node, cloud. It's a world I don't live in too much. For the edge node stuff. Readiness we talked about in terms of training for safety and occupational health services, preparing the energy side of things. I think that's it. Oh, left this on here not because you care about the facilities, but because the picture on the top right and two on the top right is a project we have with the Air Force where they're taking ground support equipment from the flight line and hybridizing it. So this is a Halverson loader to load cargo planes. Basically goes up and down to match the height of what you need to load. They did a hybrid, basically hybridized it, and now they're doing an all-electric version as well. They did that with some of the other light arts for the middle. So there's a lot of work with the Air Force doing that. Okay, so that's EBC side of things. So CTC is the nonprofit side, EBC is the for-profit side of CTC. They do have this really cool system that they developed. It's called Carriage Stream Tow Recovery. It's basically a mine sweeping system. So they drop the buoy in the ocean. It's on a cable, and it's basically the deployment, and then getting it back into the aircraft. That system is what was developed by CTC, and now I think we're selling the systems to the Navy at this point. So that was a very complicated project that took many years. They also have some coatings that do some special things for military applications, and some specialized tools we made for the H-60 toolkit to make some of the issues they were having with maintenance and refurbishment. They were scrapping a lot of stuff while doing it, just taking a lot of downtime. So we made some specialized tools to do things faster. And that's it.
Thank you so much.